Okay guys, I've decided to make a quick video for the problems on Unit 8. As I go through this, you might want to reference your exponent laws. Probably the most prominent one is the quotient rule, which says that whenever you divide like bases, you subtract the exponents, as well as the product rule, which says that when you multiply like bases, you add the exponents. So I'm going to have these handy. If you don't have your copy, go to my website, print it out. The answer key is at the bottom of that link. So I'm just going to do one from each section, again referencing my exponent rules. So we're going to start with problem number 1. What we're going to do is we're going to sort this thing out. We're going to make a fraction with just the numbers. We're going to make a fraction with just the x's. And we're going to make a fraction with just the y's. Now you notice over here there's nothing in the bottom, but this y to the negative first is in the numerator. So I'm going to originally write it there, and then I'm going to put a 1 as my denominator. Okay? So now we start reducing. 6/9 is 2/3. Remember, you can use your calculator to reduce fractions if you need to. Okay? Now here's where we start using our rules. I'm dividing these bases of x, so I'm going to subtract the exponents. Again, I'm going to start the x in the numerator, and I'm going to subtract from top to bottom my exponents. Okay? So we'll do that in our next step. Now over here, negative exponents simply mean I'm in the wrong part of a fraction. I'm in the top with a negative exponent. In order to fix that, I'm going to put it in the bottom with a positive. Anytime you switch positions in the fraction, you're taking the reciprocal, and that's the decoding of our negative exponents. No negative exponents allowed. So just switch positions, make the exponent positive. That means my numerator is now a 1. So if I actually subtract those, remember you can use your calculator. 4 divided by 5 minus 10 divided by 1 divided by 10. Math, enter, enter. And that's going to be x to the 7/10. Okay, so now at this line you can see that all of my exponents are positive. Okay, my bases are written once, so now I'm just going to multiply the tops just like I did in middle school. Tops times tops. 2 times x to the 7/10 times 1 will stay 2 times x to the 7/10. In the denominators, 3 times 1 is 3. 3 times y to the first is simply 3y. There's my simplified answer. Now the first 5 work similar to this. If you go to problem number 6, we're basically going to do the same thing. I'm going to sort these things out. 1 for the numbers, 1 for the A's, 1 for the B's, and 1 for the C's. Now I've done no math, I've just separated them out, but again, if I multiply all these numerators, I get the original numerator. If I multiply all these denominators, I get the original denominator. Okay, so now I start reducing. 12 over 10 is 6 over 5. I am not going to write any decimals today. We love fractions, at least today. Over here, I'm going to subtract my exponents from top to bottom. Be careful, you can't substitute a negative sign for subtraction. This is 6 minus a negative 1. Make sure you do that. If you don't get that subtraction right, the problem's over for you. 5 minus 2 is easy. And over here, a negative 3 minus a negative 2. Okay? Now again, if you struggle with subtracting negatives, you need to use your calculator. Okay, so this is going to give me a to the 7th. This is going to give me b to the 3rd. Wonderful, positive exponents. This is going to give me c to the negative 1st. Alright, this guy's holding me up. So again, just like in our last problem, when we had a negative exponent, we fixed it by simply changing positions in the fraction. You're in the wrong place, bud. Alright, now you're in the right place. So let's come down here to this c. Alright, you're in the wrong place, bud. So we're going to put that guy in the denominator with a positive exponent. Everything else stays the same because they have positive exponents. You only switch places in a fraction if you have a negative exponent. And so now everything is positive. We're going to multiply our tops. That's going to give me 6a to the 7th, b to the 3rd, and the denominator, 5 times 1 is 5 times a single c. There's our simplified answer for problem number 6. All right, number 11 through 15 or whatever is the same thing. Don't freak out. We just have a whole bunch of alphabet soup. We're going to use our rules. The numerator is a single base, so I'm just going to let that guy ride. But if I notice down here, I'm multiplying. If I cover that up, I'm multiplying like bases, so I'm going to do what with my exponents? I'm going to add them, so that's going to be b plus c. Okay, so now I've made the fraction to where it has a single base in the numerator and a single base in the denominator. My rule says that I'll write my base and I'll subtract my exponents from top to bottom. So I'm going to subtract these two things, right? Okay. So from top to bottom, my a, and then a minus, and I have a b plus c. Now, because I have a group, I'm going to need to use parentheses. Okay? And so my answer could be z to the a minus parentheses b plus c. Or if I distributed, okay, and got rid of the parentheses, remember I'm really distributing a -1, that's going to change the sign of the b and c. So I can write it as a minus b minus c. Either one of these answers is acceptable. On number 16, we are using our volume formula. So if you look at problem number 16, what I've done is I've taken the length from the table, I've plugged it in as 6x squared. I don't know the width, so I've put a little box, that's what I'm looking for, question mark. And then the height is told to be 8x squared y. Now remember, that's 8x squared y to the what? To the 1. I'm going to make sure I pencil in all exponents because I'm really just trying to figure out what's missing. Alright, so the left side, all of this on the left is equal to what's on the right. So I have a 6 times an 8. Well, 6 times 8 is only 48. So the question becomes, 6 times 8 is 48, but what do I multiply it by so that I get 336? Well, calculator will help us out on that. So I'm going to take my 336 and I'll divide it by what I already have, which is 48. 6 times 8 is 48. So that leaves me with a 7. I need a 7. So if I erase this question mark right here, I know I need a 7. And if you want to check it out real fast, 6 times 7 times 8 is 336. So I have my regular numbers correct. My answer should have a 7 in it. So now let's look at the x's. This tells me I have 2 factors of x. This tells me I have 2 more factors of x. And so altogether I have 4 factors of x. Well, wait a minute, I already have 4 factors of x over here. So these guys right here are good. I don't need to put anything in my answer, so my answer doesn't need another x. I've already got what I need. So let's look at the y's. The only thing left, what I got? I've got a single y over here. But I need, how many? This means I need 3 of them. Alright? So the only way that 3 factors of y will equal 1 factor of y is if I put in 2 more. So now they would be equal. So we know that's y squared. So my answer for number 16, my width, is going to be 7y squared, because now I have the same thing on both sides of the equal sign. All right, let's go to problems 21 through 25. You need to memorize this relationship between a fractional exponent. When you have something raised to a fraction as an exponent, the top part of your fraction, your numerator, I call my n number. It will go inside with my radicand. That's what we call the base now that it's under a radical sign. And my denominator will go on the outside. It will go in this little valley known as the index or the root. So if I look at problem number 22, I have 5 to the 1/2 power. So my radicand is going to be a 5. I've got to keep that in both places. Okay? And so now my top number, my n number, will mean that I have a exponent inside underneath the radical sign of 1, and over here my index or root is going to be a 2. Now if you look at your answer choices, you might be a little puzzled right here because you don't actually see this. Alright? But what I need to tell you is this is a square root. It is the most common. Okay? A square root, you're probably familiar with this. You learned it in middle school, maybe earlier. Okay? It's most common, and because it's most commonly used, we get a little lazy and we don't put that 2 in the index, in the root. So please make a note that these two guys right here are both square roots. Alright? It's so common that we just don't write the 2. So right here there's an understood 2 there, so we're going to pick A. Alright, the last ones are simply mix and match. We're going to teach square roots in more detail after the STAR test. So as we do these particular problems, grab the calculator, and the square root button is second x squared. Second x squared. See a little check mark happening right here? We type in 12, and now it's very important to notice in the problem the square root of 12 stops. So I need to tell the calculator to stop. I'm finished with my square root, so I'm going to use the right arrow. So if I come over here and press the right arrow, notice it kind of chops off the square root. I need that. That is important. If I don't do that, I'm changing the problem. Notice that the plus sign that is not under a square root is not under a square root in my calculator. Make sure that you right arrow out of every square root once you're finished typing in the radicand, the number underneath it. So minus 2 square root of 20, tab out. Just get in the habit of it. Now you notice that my problem looks exactly like it does on your paper. Square root of 12 cuts off there. Square root of 27 cuts off there. Square root of 20. Alright? Alright, so we're going to play the match game. So this is about 6.64418, blah, blah, blah. Okay? So what we're going to do is we're going to go through and we're going to type in all of the answer choices until we find one that is exactly like the original problem, which was about 6.64. Alright, so if we try A and B, it doesn't work, so I'm going to kind of tell you right now that the answer is C. So look at answer C. We got 9 root 3, and then minus 4 root 5. When I say root and square root, I'm being lazy. Alright, so you notice right there, Shazam, look at that. It's not just the 6, not just 644. It's exactly like. You can't be close. If your original problem is 6.644, you can't take an answer that's 6.1. Alright? Alright, that's how Unit 8 works. If you know how to do this paper, you can do the test.